My name is Anthony Cortucci, and I'm in Dr. Sleiman's EE350 lab. We're in section 3, and today I'll be talking about the LABVOLT. The LABVOLT system allows you to teach the DC electronics, DC motor drive, single-phase, three-phase, and thyristor power electronics, as well as three-phase motor starter and motor drive.
Hi, my name is Paul, and I'm in EE350, and we need to power up the LABVOLT system.
Okay, so now we're going to go ahead and open up the program. My name is Enrique, working with the EE350 lab project with LABVOT. So we're going to go ahead and open up the window icon. Going to go to all programs. Going to go to LABVOT, open the program, wait for it to load. And we're going to go ahead and choose 120 volts. Port COM1, and then OK, and then open up the oscilloscope.
Next, we're going to take a look at the lead acid battery pack. It uses up to 48 volts lead acid battery pack, as well as 4-quadrant dynamometer power supply. Power supply mode, it supplies either up to plus and minus 150 volts and can also be used as a current source.
Alright, my name is Nicholas Gall. I'm from EE350 Section 3 with Professor Sleiman, and I'm going to be talking about Station 2, capacitive load and inductive load. Both of these allow for us to add capacitance and inductance to our synchronous motor and generator, and this allows the user to switch frequencies. So now we run it.
This one is taking a voltage reading across the resistor.
Yep.
So now I'll take a current and a voltage reading.
Yep.
And then where's the 24 volt?
It says right here.
24 volt. Yeah. You know the current reading is.
So this one goes where? Sorry, where's the other one?
Yeah. So it goes.
Top
right
one
here,
goes where?
Goes into current, and then out of
Where's the
current.
voltage?
Oh, negative.
I think it looks like it's.
My name is Ray Crucis, and I'm in the EE350 lab using LABVOLT for this current experiment. I'm just going to describe the data acquisition and control interface. Right here we have the cable that comes from the output of the interface to the computer. Here we have the power to the interface. This comes with 4 high voltages, E1 through E4, as well as 4 high currents, I1 through I4. They're each fully optically isolated, comes with enough analog inputs to be able to observe all of the gates and all the signals being triggered.
Come on, man. It's more fun that way.
Were you guys able to get a graph? Were you guys able to get a graph?
My name is Enrique, working on the project with the EE350, and we're going to talk about the 4-quadrant dynamometer power supply to control the torque and the speed of the permanent magnet DC motor panel, right here, where we can create a buck chopper drive, buck boost chopper drive, 4-quadrant chopper drive. We will also allow to do a DC motor control using speed current feedback, using the rectifier filtering capacitor along with the transformer. We are able to study power diode, single-phase rectifier, single-phase PWM rectifier, and inverters, 3-phase rectifier with polarity DC bus, and 3-phase PWM inverters. So we can actually switch the operating mode of the dynamometer from dynamometer to power supply. We could also get an external power input for 120 volts, 6 amps, 60 hertz, right here, and we have the command knob right here.
We are working on this right here. This is our circuit that we built. It's just building a very simple circuit to be able to either get current readings or voltage readings through a resistor. And this is the graph that we got for frequency. There's 60 hertz AC coming from the wall. So it seems to make sense that there'd be very little change between 60 and like 59.8. And then we have on the lab view itself our voltmeter right here, our ammeter, and our frequency.
So we're going to go ahead and connect our power supply to our generator by connecting lead 1 to port 1, lead 2, 2, 3 to 3, and then we're going to go ahead and connect 4, 5, and 6, and it was a Y connector, and run it down to our neutral, and we're going to power it on. And we can see it's running clockwise. But if we switch L1 and 2, we should see that it runs counterclockwise.
So here, this is the power supply. So what we did was we connected the power supply to the resistive load, which then we split it up into two, connected the top part into the voltages and the current into the bottom part, and then this remains. I think this is the neutral, and we connect to the black part of it, which is I think the ground, and then with this we're able to get the graph. The graph for that circuit.
So that's the input voltage, and this one is with the load. So the input voltage is this yellow line right here, and this is the output voltage, the tiny blue line.
With a resistive load.
Yeah.
Turn it on. Resistor. So we have this is the input voltage. So this one, yeah, because this is the power supply. So that's this. You have done here for this power supply. So. Right now, just imagine this.
I want voltage and current.
This is the positive. This is the negative.
You read these? Then they're supposed to be the next set of E1.
So this is our LABVOLT system. Features real power signals while allowing full observation of all the relevant signals and full control of the power system, power motors. So this is our LABVOLT lab for EE350.